All right, back with part 2 of our Module 5 video lecture. We are on page 148 now. On the last page we talked about acids, one of them being fatty acids. So now we are going to look at lipids, which I mentioned are fatty acids linked together. And as you see in figure 5.7 here, in order to make a lipid, we need a molecule of something called glycerol, which links to 3 separate fatty acid molecules through dehydration reactions. Okay, so right here you see the 2 hydrogens and the oxygen coming out 3 different times. As these link together, it gives us a lipid or a fat molecule and 3 water molecules. Okay. In general, lipids cannot be dissolved in water. I'm sure you've seen this already. If you've tried to make salad dressing, maybe use oil and vinegar, shake them up and they'll always separate back out. This is called hydrophobic. When something is lacking any affinity to water, they will not mix with water. Okay, so as we talked about on the last page, we store some of our excess energy as glycogen in our liver, but we'll only store up to 4 pounds that way. After that, our excess energy we're going to store in the form of lipids or fats. And why is that? That is because lipids are a much more efficient way, as far as space is concerned, to store energy, as far as space and weight. 1 gram of carbohydrates contains 4 calories. 1 gram of protein is the same. It also contains 4 calories. So if you eat, a serving of carbohydrates or a serving of protein that are the same weight, you're basically getting the same amount of calories. However, fat contains 9 calories in 1 gram. So you can see how if a body is storing it, it can store a lot more energy in fat than what it can in carbohydrates or in protein. All of the food that we eat, all of the energy we get, the calories we get, come from those 3 sources, either carbohydrates, proteins, or fats. Alcohol is the only other thing that we can get calories from, and of course we don't recommend you get many of your calories from alcohol. We just focus on the other 3. Okay. Now, you probably have heard about saturated fats versus unsaturated fats, and the book doesn't do a good description of this, so I printed something else out here. As you saw on the other page, and I'll show you here, this is a saturated fat. We have all these carbons linked together with single bonds, and they form this nice straight chain. To have an unsaturated fat, I'll show you this one up here. Let it focus, there we go. See, we have carbons with double bonds between them, and where those double bonds are, they're actually missing hydrogens. We come over here, there's another one, it's missing a hydrogen, and another one. This is a polyunsaturated fat. It is missing hydrogens, it is not fully saturated with hydrogens at 3 different places. We also have a monounsaturated fats where there's just one space where hydrogen is missing and there's a double bond between the carbons. Because these fats have these kinks in their chains, you can imagine that when we link them together into a group of 3 with the glycerol over here on the side, that they're not going to stack as nicely. And it's that lack of stacking tightly that allows them to be liquids at room temperature. So unsaturated fats are going to be ones you can pour at room temperature, vegetable oils, olive oil, things like that, whereas our saturated fats are going to be more solid at room temperature. Butter is a saturated fat, coconut oil, lard, tallow. These are our saturated fats like this. You've probably heard about trans fats, and people talk about how trans fats are so bad for us. Trans fats were created by scientists because they would take our polyunsaturated fats, like vegetable oil. Ryan, he's showing me cars. Okay, sorry about that. We would take these polyunsaturated fats, which come from plants. Our plant fats do not contain cholesterol. And since people thought that cholesterol was bad for us, they decided, well, let's take these polyunsaturated fats, break up our carbon double bonds here, stick on some hydrogen bonds, and make our vegetable oils into saturated fats. Then we would have a saturated fat with all the properties of a saturated fat without the cholesterol. And that's how that all came about. And those are called trans fats. If you study this more in depth in another class, you'll learn how these artificial bonds are actually different and are called trans bonds, how they are different than the natural saturated fats that you would see here. And over time, scientists and dietitians have realized that those trans fats are actually worse for us than the cholesterol-containing saturated fats. Okay. Oops. Okay.